Okay, so in class today we were working on a couple coffee cup calorimetry problems, and it didn't look like we are completely mastering the concept yet. So hopefully this explanation kind of helps you to clarify what you need to do when you're doing these problems. The first problem, we were combining two solutions, and they're reacting and increasing the temperature of the liquid water that they're reacting in. And we're trying to figure out what the energy associated with that reaction is. So to draw you a picture of what's exactly going on, we've got our two solutions being poured together. They're going to react, and when they react, the temperature of the water increases, okay? They also tell you in the problem that the density of these solutions is 1 gram per milliliter. They give us the volume of the solutions, and they gave us the molarities. In this case, the molarities do not really matter. Maybe if this was a multi-part question where you had to find the mass of the precipitate later, then the molarities would come into play, but you don't need the molarities at this point. So to figure out the energy associated with the reaction, the first thing you need to do is basically plug into Q equals MCAT. What you're going to do, the mass that you're using for the Q equals MCAT is going to be the volume of both of the solutions added together. So 250 plus 125, that's 375. And keep in mind here, so for every milliliter, that's 1 gram. So if we have 375 milliliters, that's 375 grams. So there's the mass. This is happening in an aqueous environment, so we're using the specific heat of water. Okay, and then our water changed from 21.15 to 22.9. That's a 1.75 degree change in temperature. Okay, so plugging all this in, what this is telling us is the energy absorbed by the water when the reaction occurred. Okay, so to raise the temperature this much, the water must have absorbed this much heat. Okay, that's what this information is telling us. Now remember, where did this heat come from? The heat came from the reaction that happened inside the water, and that's the reaction itself. Okay, so the heat of the reaction is going to be exactly equal to that. It's just going to be the opposite sign, because this was the water absorbing the energy, so this is the reaction releasing the energy. Okay, so thinking of it that way, there's the energy released by the reaction, and keeping sig figs in mind, I round it to 3 sig figs, and there's the energy released by the reaction. Okay, and again, I know the reaction was exothermic because it heated up the water, and so the reaction itself must have released energy into the water in order to raise its temperature. Okay, so that's all you had to do with number 1. I feel like a lot of people got tripped up on the molarities, but again, the molarities were not required in order to figure out number 1. Okay, on to number 2. For number 2, we've got 0.4 moles of calcium chloride dissolving in 125 milliliters of water. They give us the initial temperature of both substances, and they're saying, okay, if 542.9 kilojoules of heat energy is released by the reaction, what's the final temperature of the solution? Okay, so let's take a look at our picture here. Again, it's always helpful to sketch out a picture if you're going to get it confused at a problem. So I've got my 0.4 moles of my calcium chloride. I've got my 125 milliliters of water, and I know that water is at 25 degrees Celsius to start out with. This is, again, going to be another Q equals MCAT problem. So the first thing I'm going to have to do is figure out the mass of the calcium chloride that I'm adding. So 0.4 moles times the molar mass. Excuse me. And that gets me the mass of the calcium chloride added. At that point, Q equals MCAT uses the specific heat of water, which is in joules. And right now I'm working in kilojoules, so I need to turn my kilojoules back into joules. So to do that, I convert to joules by multiplying by 1,000. So now I've got the energy in joules, okay? So now, again, so think of this conceptually. So it tells us that the heat of energy released by the reaction, so this is the reaction happening inside the water as the salt is dissolving, is this much. So if it's released, that means it's also absorbed by the water. So released by the reaction, absorbed by the water. So if this is the heat absorbed by the water, this is the mass of both the 125 milliliters of water plus the mass of the CaCl2. We have to add them together because they technically add together to make up the new solution. Okay, so adding these two together to get the mass, we use the specific heat of water, and this is going to tell us how much the water's temperature is going to change. Okay, so heat absorbed by the water, total mass of the water including the stuff dissolving in it, specific heat times change in temperature. And in this case, we're solving for the change in temperature. Our change in temperature is 766 degrees Celsius. So our final temperature of the water will be its original 25 plus 766, which ends up being 791. Okay? Because remember, this is just the delta T. That tells us how much the temperature is changing by, but it was originally already at 25 degrees Celsius. Okay? And it tells us in the problem that there was energy released by the reaction, which means it's going to be absorbed by the water, and therefore the water temperature is going to go up. Okay, so I hope that sheds some light on these problems. We're going to do some more practice in class soon, but I think it's just a matter of doing a bunch of different problems over and figuring it out that way, okay? So I wish you the best of luck. If this still doesn't make sense, come see me.